Good afternoon, friends. So, yesterday we have seen that power can be controlled by sharing options of adjacent TSS. But another way is to provide capacitor bank. It is also controlling the maximum. Why? If there is low power factor, MVA will be more to deliver same power in low power factor. So today we will discuss about the capacitor bank, shunt capacitor bank, because in our daily shunt capacitor bank is mostly used, but in Mumbai or western side they are using switching capacitors. It is somewhat costly and complicated, fully automatic control system. But our shunt capacitor bank is manually controlled. Now I will discuss about this capacitor bank. Okay, friends. Capacitor bank to improve low power factor to reduce the energy bill from penalty. We know that for resistive load, the angle between voltage and current is negligible. But for inductive load, it will lag, and for capacitive load, it will lead. Maybe lead or lag, but it will create some angle, and utilization of power will be reduced than the apparent power. Means we are absorbing from source, and how much we will utilize it. That means due to low power factor, with a fixed power to be delivered, we need more power or more current from source with low power factor. So it has been seen that traction load is mainly inductive and raise the low power factor by inserting capacitor bank In shunt capacitor bank are designed as per load pattern, means some area is mostly loaded, some area moderately, but some section having very little traffic. Shunt capacitors are fruitful if the section is loaded, but with little traffic, the power factor again may be low due to leading power factor. Our motto is to keep around 1, but if leading again an angle will form and hence low power factor. Unity power factor means the angle is 0, but leading or lagging the angle will be more than 0.